this work, we study what is happening before large earthquakes. We reviewed several studies that used geophysical data, mainly seismological data and geodetic data, that focused on detecting signals in the period preceding earthquakes. So by this analysis of many studies, we understood that there is, first of all, a sort of limitation from the data, meaning that different studies use different datasets, but also different methods, and we have also an incredible improvement of datasets and methods in the recent times. And this is the first issue that we found, that there is a lack of homogeneity in understanding what is happening before earthquakes because of this data problem. But when we dig a little more in details into these many parameters that we extracted from many studies of earthquakes, we understood that there is also an intrinsic complexity of the processes that are occurring before the occurrence of a large devastating earthquake. This complexity is somehow telling us that each earthquake has an history that brings to the rupture that is unique. So most of the processes that we highlight show that there is an increase of stress in the fault that is coming from different temporal and spatial scale, and that eventually bring the fault to rupture. And we have no clear evidence from the studies that we reviewed of an intrinsic process, so something that is clearly telling that there is a physical process that is bringing to an earthquake. So this seems like a little bit pessimistic, but instead is an important advancement, because we have a clear evidence that what we can observe with geophysical data is the increment of stress. And so these observations, when we put them all together, they tell us that there is a complexity of processes that occur before earthquakes that eventually bring to the rupture. And this new view that we proposed, it includes several spatial and temporal scales, several processes, and it can help us in the future to set, for example, numerical models that can help us to understand how earthquakes occur. But it's also highlighted that there is the need to more near fault observations, both geodetic and seismological, and perhaps new way of analyzing our data to try to catch if there are other processes that are more related to the intrinsic physics of an earthquake that is coming.